Today we're going to pick up with our work on derivatives of inverse functions, starting with generally thinking about inverses given values of the function, and then digging into inverses of trigonometric functions. So these are going to be our we do problems today. If you haven't tried them yet, please pause the video and give them a go. So we're given this function f of x is equal to x squared for x greater than 0. And our inverse of that function is the square root of x. Find f prime of x, the instantaneous rate of change, anywhere on the interval for that function x, our derivative. So this portion I think most of us are comfortable with by now. But it's always good to just keep showing our steps. So we've got f of x equals x squared. And then when you do that derivative, you bring down your exponent, right? And you make the exponent one smaller. So our derivative is 2x. And then we're asked for the derivative of the inverse function. So we're going to just go ahead and use the notation I have on the right here, which is one of our ways of writing the derivative of a inverse. All right, we're just going to be substituting into this rule. So what this says is the derivative of an inverse is the composition of the derivative of the original function and the inverse function. So what does that mean? Well, it means that I'm going to be looking at my derivative with square root x, my inverse function, as the input. So I end up with, when I put square root x in as my input into this function over here, I end up with 2 square root x. So this is my inverse derivative. So we've got our 2 answers now. Let's just kind of prove that what we've done is correct. So to prove that, we know how to do the derivative of square root x. Let's go ahead and do that. So square root x is the same as x to the 1/2, right? I'm going to switch colors just so we have a little bit of a distinction here. Whoa, that is really big. So it's the same as x to the 1/2. We use our power rule once we've rewritten that as a fraction. So the derivative of that inverse, that's just another way to write it without the dx, right? We would pull down that exponent and make it one smaller. And negative 1/2 puts us on the denominator, and the half power is the same as the square root. And lo and behold, we get the same answer, okay? So that's our first encounter with the derivative of an inverse. Let's continue now and look at some problems where we're given values for the function instead. So for each problem, I'm just going to write our rule down because it's going to be important. We're going to be using it again and again. All right. So here I've got f of 3 is equal to 9. We know our inverses swap our x and y because it goes in the other direction. So that means that the inverse of 9 is 3. All right. So the original function has the point 3 comma 9. My inverse is the point 9 comma 3. So that's important information to identify right off the bat when we're working with inverses. We're now looking for the derivative of f at the point of the inverse at the point 9. And it would appear I did not give you enough information to do this problem. So let me give you some more information. We would need to know the derivative function at the point 3. All right, so now we have enough information to do this problem. Yikes, sorry about that. So we're looking at this derivative. So we've got 1 over, let's write it out again. So now we're looking at the point 9. So I've got 1 over f prime f inverse of 9. So 1 over, and then f prime of, the inverse at 9 is 3. And then the derivative at 3, I just told you, is 1/2. All right, so without that information, this problem would be impossible. So our derivative is 2. I apologize for not giving you that information in the prompt. Now we're going to be looking at a table, and hopefully I didn't mess up this problem as well. But now we're talking about two functions, f and g, where g is the inverse. So this is using the other notation for an inverse. So we had that alternate definition where the inverse was the function g of x. So that alternate way of writing it was the derivative of g, where g is the inverse of f of x, is 1 over f prime of g of x. It's the same thing. It's just an alternate way to write it. So we're using kind of the alternate language with this one. So we're going to consider this table of values and that relationship as we answer these questions. So I've got the inverse, all right, at 8. So alternate way of writing this, g prime of 8, because I was told that g is my inverse. So both of these are equivalent. Those are the same. All right, so let's go ahead and write it out. We've got 1 over f prime, all right, and we can either use g of 8 or f inverse, all right? So in order to do this, we need to know the values of our inverse, which we do not have on our graph here, right? So we need to, in our table, we don't have an inverse function here. So I'm just going to make a column for my inverse. And these are our input and output, right? This is like 1, 4, and 4, 8, and 8, 0. So we know that the inverse just swaps those, right? So when our input swaps, we've got, I think it'll be easier to write it as points. So f negative 1. We've got the points 4, 1, 8, 4, and 0, 8. So all I did was I reversed the input and the output. All right, it's easier to see like that, I think, than in a table. So when we're looking at the composition of the derivative and the inverse at the point 8, the inverse at the point 8 is 4. So then we look at the derivative at 4, and we've got 3 over 7. Multiply by the reciprocal, you're going to end up with 7/3. Down here, we apply our rule. All right, and the inverse of 4, looking at our points over here, is 1. F prime at 1 is negative 4/3, so I've got 1 divided by negative 4/3, which is negative 3/4. All right, and now we're into inverse trig land. So I've reproduced our rules on the right-hand side in both the we do and I do sections, so that should be of assistance to us. All right. This is a little sloppy. There should be parentheses here. All right. So each of these two we're looking at right now actually has an inside function, because there's something variable expression happening with our x before we have the inverse cosine. So this is practice with the chain rule as well as these new kids on the block, these inverse sine, tangent, secant, cosine, cotangent, cosecant. All right. Just a note to self, we could also write all of these as arcsine, arctan. That's another way of saying inverse. So this is the same as saying arc cosine. This doesn't change the meaning, it's just an alternate way of writing it. And we need to be familiar with that because we could see either. So when we're looking for this overall derivative, we're going to have to do our inside-outside business. So f of g of x, when we're considering what's my outside, well, my outside function is the cosine, the inverse cosine. My inside function is that negative 5x to the third. We have to do the derivative of the outside with the inside staying the same. And that's going to be our cosine rule here, which says we've got negative 1 over the square root of 1 minus our input here is g of x. So g of x. Oh no, running out of space. Squared. All right, and we know that g of x, let me just move over a bunch, is negative 5x cubed. Yeah, cubed. So we can substitute that in. And then following through. All right, so we've got our derivative of the outside with the inside staying the same, right? Now we just need to follow through with the derivative of the inside and then multiply the two results using our chain rule. So the derivative of this inside is negative 15x to the 3 minus 1, which is 2. So the chain rule says that if I'm finding my overall derivative here for this guy, I'm going to do f prime of g times g prime. And that's going to be negative 15x. Well, I guess I could write it in the same order. Get it together, Donahue. And there you have it. That's our solution. All right. So I'm going to make all this disappear so I can have some space to work on this next problem. All right, so now we're going to be looking at tangent of 2x to the fourth. So same idea. I'm going to just start a little higher this time since I ran out of space last time. So my inside function here is that 2x to the fourth. So I've got inverse tangent of 2x to the fourth, so I can replace that with gx. And then I've got my g of x. That inside function is 2x to the fourth. So the derivative of the outside with the inside staying the same is that arctan derivative, which is 1 over 1 plus x squared, so g of x squared. And then follow that through, we've got 1 over 1 plus 2x to the fourth to the second, 1 over 1 plus 4x to the eighth. And then our derivative of g